advantage of the generalized expertise in the room. And can I just... and see if we can answer some questions. And so is this your question? Would you like to provide any context or?
Oh my God. I'm not prepared to introduce my question. So actually my data set is a friendship data and how there are, how many classes? There are 21 classes and so my research question is, it's my very first step of my thesis paper. So I want to see that how that friendship network is constructed. So I want to see their structures. So I'm trying to see that how mutual reciprocity and or transitivities are exist in my friendship network. But my question is, I want to see, I expected some gender difference maybe exist in there, but I have no idea to create a interaction term with gender and specific network characteristics like transitivity with males or transitivity under girls. So that was my question, but I think on your lecture today, I got a lot of help.
Okay. Well, that's usually a plus. So the general question is it possible to fix, for example, a GWESP term that would have an interaction term by male or female, or some of the other in-degree and out-term question terms? And I think the last one is the easy one to answer. The GWESP does not currently fit with the direct interaction, but you could do the subset of the network effect and then fit a model with GWESP in it for one subsection of the metal, and then have a reference to the other. Would that be a fair statement for others in the room that might know better than me?
Well, I can't remember because there's constantly stuff being added, so I don't remember if there's currently, in the latest edition, and like a new version has just been pushed, whether there's inhomogeneity added in GWESP. But I can back it up a bit and challenge you to say, what do you mean by gender and transitivity? Because that's a complicated question. You can mean a lot of things. And then I also want to be more provocative and say, do you want to know about, do you think there are, and are there differences in the realized network by gender and transitivity? And do you want to explain where they come from, or do you want to fit an effect for it? Because they might not be the same thing. So if, for instance, what you're talking about is that cliques have more homogeneity, perhaps, by gender than you'd expect by chance if you randomly allocated people to cliques. So that would be one thing you could be looking to mean. If that's the case, then obviously first we'd want to establish that that is true in the network, which that would be a kind of a permutation test kind of question. And then you would want to say, can I explain that? And maybe you need a term like you're talking about to explain it. But maybe if it's there, that emerges from the interaction of, say, a more basic mixing effect, degree effects with closure effects. So I can get a situation where there are, say, degree effects and basic mixing effect, and then there's a generic homogeneous closure effect, and the two things combine to create clusters that are extra homogeneous. And it's not so much that there's specifically, males trying to cluster with the males and females trying to cluster with the females. It's that, males tend to mix more with males, and females tend to mix more with females, and we tend to cluster. And when you put those two things together, you get an emergent outcome. So you may or may not need a term to describe that emergent outcome. But it all comes down to what is it that you want to know, what do you think is happening?
Yeah, actually, my research question starts at an interesting article that they said boys are trying to, when they feel some peer pressures, pressure in triangle relationships, boys are trying to add more threads, but in contrast, when there are triangle relationship happens, girls are more likely to just
So-
So is this Lynn and Miller's? Is this Lynn Smith Love and Miller Makers? Chapter?
Who's your
Oh.
Oh.
They had a paper like that anyway.
Yeah.
But
But-
nice,
but-
nice chapter.
That question strikes me as more along the lines of a CNO or another kind of dynamic model, where you're saying, given a configuration at time one, what's the likelihood of those ties either remaining, depending on the granularity of your data, or not in the next period. So do you have dynamic data?
Actually, I have a not I don't know. I can say that it's dynamic data because I have a current friendship data and then I have a prospective friendship data. So which is that peers nominate who I want to be your friends in future. So I think I can.
That's an interesting structure, actually. So you have realized friendships and aspirational friendships.
Oh, that's cool.
My aspirational friends are much cooler than my current friends. Other generalized advice? You have other questions here. In the interest of perhaps not keeping everyone here today, is there a second question you'd like an answer to?
Yeah, my second question is just general question about urban term. And I saw that usually urban term, for specifically for that urban term, that all degree term, there are 4 nodes are existing. And then I have a question about how can I interpret that one? Because does that exactly mean when there are 3 people existing and then it predict the 4th people's relationship, or is it just generally represent that if there are existing real ties are existing and then it just means predicts the another next tie, not exactly the 4th person's tie.
Yeah, so the O degree and N degree terms, as I understand them, are effectively row and column effects. So these are volume effects, not as opposed to target effects. So you're not saying that this dyad is going to happen more or less. It's this person is going to give more or less ties. Fair?
It's O degree or N degree, right, that you're talking about, and those are actually, they're neither of those things. They're actually count effects. So they're propensities to have, K ties. So you have, say, and in fact, I forget the directed O, but let's just talk about degree. So then, so you have a degree 3 effect. You can think of that as representing a social force. So you can think about ergon terms as representing a force in the network, and the force is pushing the network to have or not to have something. So a positive O degree 3 says there's some force in the network that is tending to encourage people to have exactly 3 ties. And so, we're going to think in a conjectural dynamic way. It'd be sort of like if I had 2 and I could add 1 to get a third, that would become favorable. But if I had 3, dropping 1 would be unfavorable, and adding 1 would be unfavorable, if that was the only thing in the network is that. So that it doesn't say who it is who's doing it. It's not specific to the individual, and it doesn't about anything else. It's literally to have 3 ties. And that sounds a little weird if you just have like 3 per se, although there are some networks where having special numbers might matter. But it doesn't sound as weird if it's 0, or it's an isolate, or 1, depending might matter. But usually, O degree terms appear in not one of them alone, but we have a whole suite of them, and that's where things like the geometrically weighted degrees. The idea is that you have a whole distribution of parameters on those things that represent differential propensities to have higher or lower degree. But they're implemented by a whole series of those things that represents how favorable it is to have K ties. So that's what that particular term is. It's one of many ways to parameterize degree.
And the thing I was describing is the node cove questions. So I apologize for that.
So if my question here asks the participants that you can nominate your friends up to 2, and then am I violate the assumption for this using this O degree?
So if I understand it right, if you capped your survey at out degree 2, an out degree 3 term would be really hard to fit. Yeah.
Well, it says it's
Yeah, you have to do, sorry, there are ways to constrain the grass area and sample area estimation is not considered above area 2. So it's possible to put that constraint in the estimation, probably specify that.
You talked about that earlier.
Right.
So that would be, well, the survey question says name of those 3 people, is that the one?
Yeah, my question here was, you can nominate up to 3 people, but
Yeah.
I just think if my question here was up to 2 people, then does not make sense at all to use that working three or not?
Yeah, if you had up to 2, then you certainly wouldn't want to put a degree 3 term in there, because it's impossible. The model is going to be trying to scratch its head, trying to figure out why is somebody have 3, or they'll put a negative infinity on the coefficient, but you put constraints on that one. Now, but let's say you had that questionnaire item listed, named at least 3. In that case, you would want to put a support constraint that you can't have more than 3. But that might be an example where you might want to have a degree 3 because you have, as part of my criticizing these survey items, you have really put a demand effect to, why don't you name 3 people? Right? That's what you kind of told me. 3 people is what I'm looking for, give me 3 people. So you might expect that there's going to be an intrinsic tendency for people to name 3 people because you made that very salient to them. And so putting that effect in the model, that might make sense, right? Because you think it'll be a very attractive number per se, because and that's a great example of why that can pop up, because sometimes the survey will prompt people to give that number. And if the poor model is trying to figure out why all these people have 3 ties, if you don't include that term in there, right, you may have a hard time.
Awesome. All right.
My last question is, I just started studying Turban, and I found that there are some specific terms like persist, form, dissolution, change, and cross terms in Turban. But even though I read the definition of cross term, but I couldn't figure out what does it work. So if somebody can give some example when we use the cross term, then I appreciate it.
But I've never used the cross term.
I've never used it either.
I can only play Popple, and he stuck it in there, you know. But I mean, you know, I can read it in real time and tell you what you can already tell by reading it. But it's just treating the networks as if they're simultaneous, and it's just putting in effect this as a general tendency. But why would you do that? Well, what if you think you have something that is sometimes there are things that occur at different points in time, but the fact that they occurred over a time series is not relevant, right? They really do represent independent replications. Just one happened to be before the other. You have a bunch of people who go to an amusement park and they go on the rides and then they check some box about how happy they are, right? And some of them go at one time and some of them go at another time. But if they don't interact with each other, you're analyzing their survey reports, you probably just treat them as a sample. You wouldn't think, well, I have to have a time series of when they went to the amusement park. This is like that for networks, right? So your network's going to the amusement park, so to speak. And the fact that one is earlier and one is later is not relevant to what's going on. They're really just a sample of networks. That's what that's. Whether you believe that's relevant in your case or not is well.
All right. So thank you, folks. This was a relatively intense day in terms of the cognitive load for what's there. And tomorrow we will we have a half day, starting in the morning with simulations.